Hey everyone, welcome to your Play Posit for the week. This week is a little bit different, right? I did want to congratulate you guys on your hard work for the month of February and earning that snow day. So hopefully you're watching this on Monday, March 8th. And you guys, we don't have class tomorrow on Tuesday, March 9th. That is your snow day, and I'm going to miss you so much. But just a reminder that there are those optional snow day sessions on your plan that are going to be super fun. And you can certainly use that time as you see fit. You can use it to catch up on things, work ahead, or just take the day off. That's why it's there for you. And then looking ahead into the week, don't forget that we have those extra help sessions with Miss Jadala on Wednesdays at 11 and 12, and then also Thursdays at 9, if you don't already see me at 9. So definitely a lot of opportunities for you guys to get some math in this week. And the first opportunity is going to be this play posit. And we're going to be basically wrapping up Unit 2, which is super exciting. Before we do that, I was hoping that you guys could, this squirrel makes me laugh. And if you know what I'm thinking about, you're probably laughing too. I'm going to put this link in the play posit for you guys to go ahead and fill out. And it's just a few questions, just basically asking how you're doing, what you did over the last week and the weekend. So I'm going to put that Desmos link into the play posit for you to click. If you're watching this on ViewPure or YouTube, then you can definitely go to student.desmos.com and enter this code, and it will take you to the same thing. I'll also be putting this link on our recording tracking document in case you want to get it from there as well. Big exciting thing happening this Friday, March 12th. We'll be celebrating Pi Day, and there's a bunch of math teachers, myself included, Miss Miner, who else? Miss Kraft, a ton of them. Miss Gilner, just think about that. Miss Gilner and Miss Warren, just a bunch of math teachers are getting together, and we planned what I think is going to be a super fun and informational and interesting session on Friday at 11. So come celebrate Pi Day with us. You can get some more information about that session in the middle school newsletter that went out. So don't forget, these are just some reminders because this week is a little bit different because of that snow day. That you have this play posit, finding factors. I'm sorry, not this one. That's from last week. So last week when you guys didn't have any sessions, you had that play posit on Thursday the 4th. So don't forget, make sure you're watching that one. And then here's today's, the Unit 2 wrap up. That's this one. And then on Thursday, we will have our regular introduction to Unit 3 play posit. So essentially, we don't have live class on Tuesday, but because this is a high school level class and because we do have that material to cover, I basically wanted to give you guys that instruction. So we have that in the form of the play posit. But the cool thing about the play posit is you can do it whenever you want, whenever it fits into your schedule. Make sure it's done before next time we meet, which is, so you have, 6 school days essentially. But that is kind of the difference of the live class and the play posit, right? Because the play posit, you can fit it into your schedule as you see fit. All right, here's our flashback for the day. This is where the notes start. So if you're using those guided notes, which I encourage you to do, this is where they start. And if not, then you're grabbing your notebook paper. So it says solve for W. So basically, we're just going to get W all by itself. Don't forget, I know I say this often, you can pause these recordings. So if for some reason I don't have a pause built in and you want to pause it, just hit pause. And you can try these questions for yourself and then check your work. The other beauty of a recording, right? All right, so we want to get W by itself. Here's the term that has the W. So before we can even touch that term, we have to get rid of everything else that's with it. Move it to the other side. So this is a plus 3, so we'll just subtract 3 from both sides. That's the inverse of addition. And then we'll bring down xzw and have t minus 3. Now these are all connected by multiplication. So the inverse of multiplication is division. So we're just going to divide by the items that we want to get rid of. There we go. We got W all by itself. Now you can write it like this, or you could, if you really wanted to, write it like this, where you're dividing that xz by each term. This is technically more simplified, but this is not wrong, it's just different. All right, so let's just do a little more review with factoring. I know that we've done this a little bit in class and then in the last play posit, but we're going to do some more. It says find the factors and the solution. So now we're looking at these two words here and what do they mean, right? So we looked at the last play posit. The solution is where the graph crosses the x-axis. So here's an example. This is just an example. I don't know what the solutions to this one is yet. Let's say -1 and 3. I just made that up. Those are the solutions, or the zeros, right? Remember, factors are these guys, what we find to multiply by. So this whole thing is a factor, and this whole thing is a factor. Excuse me. So if we can, we're going to find the factors and then we're going to find the solution. So step 1 says to factor out any GCFs. So when you guys look at this example, you see there's only one term with a squared. That's it. So when that's the case, you can actually solve sort of naturally. So here we can add 9 to both sides by trying to get x by itself. And that is 64. So because there's only one term with an x, you can isolate that term. You can get it by itself. Now, how do we get the x by itself? We have to get rid of the squared. You guys remember the inverse of squaring? The inverse of squaring is square rooting. So we are going to square root both sides. Those are inverse operations, so they cancel, and you get x equals plus or minus the square root of 64. Remember, the square root of 64 is 8. You can always check that in your calculator. 8 times 8. And now we do have to think about the plus and the minus, right? Because 8 times 8 is 64, and also -8 times -8 is 64. So when we're solving square roots, we do have two solutions, which makes sense, right? Because we have a squared variable, so that means we're going to have two solutions. If it's cubic, you're going to have 3. It's kind of cool that way. So those are our solutions. So let's look at this in the graph. Oh, I'm going to pull up Desmos real quick, if my computer lets me. Let's look at this in a graph. X squared minus 9 equals 55. I'm just going to put it in just like that. There we go. So you can see that the solutions are -8 and 8. So that's where it crosses the x-axis. Let's see if we can get a better picture. This is a very skinny parabola, and look how skinny that is. I wonder where the vertex is. You're going to learn how to find the vertex in Algebra 2. The vertex is that little point where it dips. Let me get back up here. Okay. So it does cross the x-axis at 8 and -8. We saw that. Those are the solutions. But remember, the factors are when we write it in this form. So we can write that as x plus 8 and x minus 8. You know, we could also write this. This is the reason why this works is because it's the difference of two squares. We have x squared minus 64 equals 0, right? If we moved the 55 over to the left, what we have here is the difference of two squares, a squared minus b squared. And that's how we got the x plus 8 and x minus 8. But we also got them just from looking at the solutions. Remember, the factors are sort of the opposite. So if we were to set these equal to 0, each of them, this factor would give us the solution, x equals negative 8. And this factor would give us the solution, x equals positive 8. And we're going to see more of that today, where you can take a solution and make it a factor. So let's try some more. Find the factors and the solutions. So right away, you see we have more than one term with a y variable. So we know we can't just solve it naturally like we did the first one. So let's get all the terms on the same side. That's a good idea. We always want to set it equal to 0. I don't know why I put that big space there. But I just subtracted the 20 from both sides and added the 7y. Just moving it over, rearranging the way that it looks. And then you should always look to see if you can factor anything out of all three terms, because it's just going to make the number smaller and easier to work with. Here, these numbers do not all share a factor. 3, 7, and negative 20. If you wanted to, you could set up that cake method and check it out. But 3 and 7 are both prime. So the only factors are 1 in themselves. So they don't have a GCF. So let's factor it. Factor the trinomial. Now this is where I say there are multiple ways to factor a trinomial. Maybe you've learned slide and divide. Maybe you like guess and check. Maybe you like the Ma method. That's my favorite, and that's the one I will model in class. If you ever want to look at any of those other methods, feel free to pop in office hours or send me an email or look on different resources like Khan Academy, even YouTube. You can look into those. The reason, and I know I've shared this with you guys before, the reason I love the Ma chart is that it always works. I personally can't get along with the guess and check method. It just takes too much time, like to guess and check. So this is my favorite method. So we're going to do the first times the last. So that's 3y squared times negative 20. So that's a negative 60y squared. So we're looking for two numbers that multiply together to give us that and add to give us the middle term. So step 1 is to start listing the factors of 60. What times what is 60? And I usually just start with 1 because that works, right? 1 times 60, and we could have the negative 1 or you could have the negative 60. Either way, either term could be negative, right? What else? 2 times 30. Let me do this. There we go. Easier for me to keep track of. And 30 times 2. So I kind of just systematically start to list them, like 1 and 2. Does 3 go in? It does, right? 20 times, so negative 3y times 20 and negative 20y times 3. Wow, there's a lot. Okay, 4. Does 4 go in? It does, right? Look, I'm doing long division on my paper. I don't have my calculator handy. Hey, it works. Okay. My goodness. 15. 4 times 15. So we have negative 4 times 15 and negative 15 times 4. All right, how about 5? Does 5 go into 60? And it does. 60 has a lot of factors, doesn't it? 5 times 12, I'm going to list it over here. If at any point you see the pair of numbers that works, feel free to stop. I think we just found them, didn't we? Because we're looking for, let me get a different color. We're looking for 7y. Positive 7y. So that's going to be this pair, right? Negative 5y plus 12y equals 7y. We found them. We can stop, finally. So we're going to replace the middle term with the two values that we found. And I know we've talked about this before that, you know, it might matter the order that you write them in, and it might not. Let me see here. I don't know why I put a squared on that. Hold on. So let's see if we can find some factors when we group them, a GCF. So if you look at the first two, it looks like we can only take out a y. So let's take out a y, and we have 3y minus 5. Let's see if it works. I don't know. I honestly haven't done this one yet. I liked, you might be like, what? That's not right. A teacher shouldn't do that. She should be prepared. And I have done these problems, but not yet for this lesson. So I think it's important for me to do them with you guys so we can come across the same potential barriers that we would when you're doing the problems. I don't want to just like feed you the right answers, you know, we're going to go through it together. Okay, let's look at these two. It looks like the GCF would be, what can we take out of 12 and 20? Well, we can definitely take out a 2. Here, let's just come over here so we don't miss anything and do our cake. So we can definitely take out 2, and that leaves 6 and 10. And then another 2, and that leaves 3 and 5. So our GCF is 4. That looks good. So we'll take out a 4, and let's see what's left. 3y. Do you see what I see? Minus 5. Yay! Yep, because 12 divided by 4 is 3, and 20 divided by 4 is 5. Ta-da! These match, so we can write our final answer as y plus 4 and 3y minus 5. There's our factors, 2 of them. Remember, factors are things we multiply together to get something. Like the factor of 60, we had all these, see, 2 of them. Here it just looks a little different. The factor is just this whole thing. Those are the factors. Now to find the solutions, all you do is you set each of them equal to 0 and solve these little mini problems. So you get negative 4 and a fraction, right? 5/3, which is what? 1 2/3, so 1.666 something. Okay, let's check and see. Because remember I said that we can use the calculator to help us. We can't really technically use it to factor. Some people like to try to, but it can cause you trouble. So here, let's just double check our work and make sure. That looks funky. Hold on. That looks so weird. Did I type that in right? 3y squared equals 20 minus 7y. 20 minus 7y. All right, the viewing window is bizarre. So I'm trying to see what kind of, oh, I know the problem. We came across this the last time. It's because I put in a y. So we do have to make sure, which is fine when you're solving. It can be anything, right? It could be T, Z, P, J. But when you're using the Desmos calculator, they have it set where the horizontal axis is the x and the vertical axis is the y. So we do have to use x for the variable. That's what it is. There we go. That looks so much better. And we have -4 and 1.66. Like I said, 7. So let's just double check. Whoops. -4 and 1.667. 5/3 is 1 2/3. So there we go. Those solutions match. So you can pat yourself on the back. All right, should we do another one? Let's do another one. This one says, how many and what type of solutions does the following quadratic have? So this how many and what type question, we're actually going to cover in our Thursday play posit. So you're going to see, we're going to see examples where there are 2 solutions. Maybe there are infinitely many solutions. Maybe there are no solutions. So we're going to see some examples of that. So let's do this. A good idea is to get everything on the same side, just so you can kind of see what you're working with, especially when you have more than one term with a variable. See, we have 2 terms here with a variable. Remember, if you only have the one term with the variable, like, where did it go? Did we skip a problem? I'll have to go back to that one. That's weird. Like this one, see, we only had one term with with the variable, so we solved for it. That's weird. Okay. Factor out any GCFs. I don't see any GCFs. And the easiest way you can tell that is, see, these 2 terms are prime. Again, 2 and 7, the only factors are 1 in themselves. So let's factor the trinomial. So first times the last is going to give us the m for our MA chart. Six times 7 is 42, y squared. Positive. Yep. So we're looking for 2 numbers that multiply to give us this and add to give us that middle term, -2y. So we can start listing the factors of 42. Well, we know 6 and 7 are 1. So 1 and 42, let's see. When it's positive, remember, we could do +1 and 42. They could both be negative, right? Because a negative times a negative is a positive. So we could just do this, plus and minus. 2y and what is that? 21? And then we'll do 3. That works. That's 14. Three y and 14y. Let's see. Does 4 work? No. Does 5 work? No. 6 works, we know, because we had 6 times 7. So 6y times 7y. We know 7 works. How about 8? That doesn't work. 9? Nope. 10? Nope. Nope. Are we done? So you can see there are actually no factors that multiply together to give us that and add to give us -2. None of these are going to work to give us -2, right? Nope. Nope. So here, right now, with our current knowledge, we would basically say no solution. And we can look at the graph to confirm that. So see ones like this in our next play posit where they're not factorable, and there's something called the quadratic formula that we can use to solve for those solutions. But let's look and see what the graph looks like and just see what's going on. Like, why can we not factor this? Why in the world? And don't forget to put it in as x's. I just wrote that down so I could come here and not get it wrong, not copy it wrong. 6x squared minus 2x plus 7. So there's our quadratic. Ooh, so you can see it does not cross the x-axis. Nope. It never will. This is the vertex and it's going up. So it's not like it's going to go up and down and maybe cross it somewhere else. This is what they look like. So yeah, no solution because it does not cross the x-axis. So taking a look at that picture definitely helps sort of solidify things. But next class, again, I'm going to show you guys the quadratic formula and to be able to tell how many and what type of solutions a quadratic can have. Because you can do this quick little test and then you wouldn't even have to use your time doing this. You'd be like, nope, no solution. No solution. All right, so let's try some. These are some questions that I pulled from previous SOLs. So I thought you could see like some of the ways that they're going to ask you these questions. So select the correct answers. When factored completely, identify the factors of this polynomial. So here it's called a TEI question, a technology enhanced item, because it's not multiple choice. Basically, anything that's not multiple choice is something that's more enhanced. So here you would have to click, these are clickable buttons on your SOL to select all of the possible answers that are factors. Identify the factors. They don't want the solutions. Careful. They want the factors. Remember, factors are things that you multiply things by, even if it's just numbers. So we need to factor this trinomial. Let's do it. So the first thing to do would be to see if there's a GCF. Can we take anything out of all three of these? And we can do our cake, our layer cake here. I see a 3. So 3 goes into 9 3 times. 3 goes into 30, 13, right? 10 times 3 is 30. 3 times 3 is 9, 39. Perfect. And 3 goes into 30 10 times. Okay. Can we do anything else? Is our cake done? And it's done. 3 is prime, so we're finished. So our GCF is 3. So let's take a 3 out from all of this. So we're going to have 3x squared minus, basically these numbers, right? When we divided, 13x minus 10. There we go. All right, now we're going to factor. So first times the last is going to give us the m for our ma chart, and that's negative 30x squared. And we want that to add up to the middle term, negative 13x. So I already see it. Maybe you do too. Let's list some factors of 30. There's a few. 1 and 30. 5 and 6, right? And then 10 and 3. I left off the x's. Sometimes I do that. But you get the idea, right? So 10x times 30x gives, or 3x gives us the 30. I have no idea. You guys see that? I don't know, do plus or minus. Whoops. This is a negative 30, so one of them has to be negative, and one of them has to be positive. So, let's see. The last one would be 15 and 2, right? I think those are the last ones. 15, 16 is not a factor, 17, nope. Okay. So when we look at these 4 pairs of factors, we need to find the one that adds up to give us negative 13. And here it is. Negative 15 plus 2 is negative 13. So we're going to replace this middle term with those two numbers we found. This 3 out front just kind of comes along for the ride. So we have negative 15x plus 2x minus 10. Remember, we didn't change anything. We just wrote 13 as 15 plus 2, or negative 13. All right, now let's factor by grouping. So we'll group the first two and group the second two. So if you look at the first two, they share a 3, right? A numerical factor of 3, and then they also share an x. So we're going to factor out a 3x. And again, this 3 just kind of stays out there in the front. Don't mind it one bit. We have an x left and minus 5, right? 15 divided by 3 is 5. Bring down that plus. And then the second two share a factor of 2. We have x minus 5. All right, we're going to write our final answer as the two GCFs, 3x plus 2, and the x minus 5. And we're done. You can see that this quadratic has 3 factors. Let me get my highlighter. It has this one. Remember, a factor is something multiplied together. So we're multiplying the 3 times this times this. So you would go up here when you would click 3, and you would click 3x plus 2, and you would click x minus 5. Those are the 3 factors. Here is another type of question you would see on the SOL. What are the solutions to this equation? And so you can see here that they have these curly brackets. So that's not a coordinate point. You know, it's not an x value and a y value. We see solutions written in curly brackets. You might see lists of numbers written with curly brackets. So it's saying that these all have two solutions, x equals negative 3 and x equals 1/2. It's just another way to write a solution set. So at this point, you know, you have a toolbox of things you can use, and you're going to get even another tool at our next Play Pause It. For now, you could definitely factor this and solve it. Or you could graph it and see where it crosses the x-axis. I did say that the calculator can't really factor for you, but I never said the calculator couldn't give you the solutions. That's what it does for sure. Oftentimes, the calculator can also give you the factors, but not all the time. So that's why I hesitate to tell you guys to use it for that. But it's a great tool for double checking. So we can find solutions using the calculator. We can't always find factors. But this one's asking for solutions, so let's try it. I'm gonna write this down so I don't forget it. And let's go to the calculator. So we have 2x squared, whoops, plus 5x plus 3. Okay, let's zoom in on this because they're kind of being squished there. Here they are. Here are the two solutions. Negative 1.5 and negative 1. So we got negative 1.5 and negative 1. So it looks like it's definitely not A, it's definitely not D. So it's either going to be B or C with these negative 1s, right? Well, it's not this one because that's 6. Just confirm 3 over 2, that is 1/2, or 1 1/2, right? 2 goes into 3 one time with 1 left over. So they do match. So it is C. And even another way to solve this problem, you could technically take each of these and plug them in to this equation. And if they are solutions, then you will get 0 when you plug them in. That would take a long time, but it is a method. All right, so let's talk about, see what I did there? Okay, let's talk about Unit 3. Unit 3 is basically going to just sort of carry over what we've been talking about with quadratic functions. So I wanted to give you a little sneak peek and show you that it's kind of just an extension of what we've been learning. Whoops. So it says write the quadratic equation from the graph. So I need to explain a little bit more. Remember we talked about how you cannot always find factors from a graph. But in our class, you can, typically. This is so strange. And when you get to Algebra 2, you're going to be like, oh, that's what she's talking about. So the difference being is whether or not you have a third factor in the front. If you have a third factor, then this method won't work. And you won't really know if you have a third factor or not from the graph. So that's why it gets a little funky. But you guys need to know for these two that I'm about to show you, you can do it this way. I just want to show you how the solutions and the factors are related. So here are the solutions, right? -4 and 6. So the way that we would write this, -4 and x equals 6. You're basically going backwards. Subtract or move the 4 over with the x. There's your factor. Move the 6 over with the x. There's your factor. That's it. You're done. Some people like to think of it as the opposite. So if the solution is negative, then the factor is positive. Because look, if we were to take each of these and set them equal to 0, then we would get those little solutions. So it definitely checks out. If you were to take this and plug it into the calculator, it would match this graph. So let's try another one. Our solutions are x equals 2 and x equals 4. Oops, I should have wrote it up here. So you can move the 2 over with the x. The factor is x minus 2. Move the 4 over. The factor is x minus 4. There we go. So it's kind of like reverse factoring. You're getting the equation from the graph using the solutions. Pretty cool. All right, that's it, you guys. Don't forget to do your play posit from March 4th. That's last Thursday. Do this play posit. And then, of course, the play posit that's coming this Thursday. Take your notes, follow along, reach out to me with any questions. Go to those sessions with Miss Jadala if you guys need or want any extra help or support. And I am going to miss you for real. I'll see you the following Tuesday. But I'm here just an email or a phone call away. Bye, everybody.